Hi guys, my name is Nick Darnell. I'm a programmer here at Epic Games. I'd like to walk you through today how we set up Lyra for cross-platform development and how we set up CommonUI to work in Lyra so that you can organize and control your UI flows. So let's hop into it. Let's start by going over Lyra's front end. So we've got options like Play Lyra, Options, Credits, and Quit Lyra. Quit Lyra is a very PC-centric option. If we dig into options and we head over to video, we've got, global illumination, shadows, very, very specific options for rendering things that you really only find on PC games, same as window mode and being able to change the resolution. Let's head back to the front end here. If we're doing cross-platform development, though, having to deploy to all the different platforms and make sure the UI looks correct in all these different circumstances is a bit onerous. So one of the things we did in Lyra was we added pretend platforms. So I'll stop this and I'll head over to the editor preferences. And what we've got here is an option called Lyra Platform Emulation Settings. So I click on that and I've got a pretend platform. And I'm going to select PS5, close out of that. And I'm going to play. All right, first difference we've got is a start screen. That isn't something that we need on PC, but it is on console. You'll also notice I have no mouse cursor. Everything seems to be oriented towards the gamepad. So I'll click that. And then now our options on here are only Play Lyra, Options, and Credits. There's no quit option anymore. If I go to Options and I head over to Video, our options that are here are very different. We can no longer control window mode or resolution. Our graphics quality options are now just pretty balanced and fast. These are the sorts of things that you need to worry about when you're dealing with a console game, and being able to quickly iterate on PC as if you were that console makes things a lot easier. All right, so now let's talk about how some of the stuff is actually set up. Let's open up the content drawer and we will find Lyra front end, which is our main screen widget. And if I click on something like Quit Lyra, you'll notice we've got a widget wrapping it called Can Exit Application. This widget is a common hardware visibility border. And the purpose of this widget is to basically allow us to filter widgets based on gameplay tags. These gameplay tags are a mix of platform gameplay tags, which come from configs for the platform. They also come from the current circumstances. So if I am using, say, keyboard and mouse, there is a gameplay tag for keyboard and mouse versus touch versus gamepad, so that you can have different widgets appear or disappear based upon the current input type that the user is using. So if I look here at the visibility query, Quit Lyra is based on a platform trait called Can Exit Application. And I can show you where that's configured. Now let's look at where some of these tags actually come from. So what I'm looking at here is the Windows game INI, which is just the configuration for a Windows deployment of the game. We've got platform-specific Windows configurations up here, and things like the default input type is mouse and keyboard. We support mouse and keyboard. We don't support touch. We support gamepads. We allow you to change the gamepad. This is the default gamepad type to use. And then we also list out controller data that needs to be cooked on a Windows build, which is useful when you want to, say, ship your game and have keyboard and controller bindings that could work with either the PS5 or, say, the Xbox gamepad on your game. We also have down here the platform traits that we actually want to be associated with a Windows game. So things like supporting Windows mode, can exit the application, on and on and on. Single online user is the one that actually controls things like the startup screen on whether or not there's a press start. Because for console games, you could have multiple potential online users and you need to figure out which controller is actually the one that's signing into the game, things like that. Needs brightness adjustment would be things like, you need to show the gamma choice when the game first boots. These things are just options we came up with for Lyra. You could add to them, whatever your game needs to support on different platforms. If we hop over to PS5 configuration, you can see it differs slightly. So the default input type is gamepad. I've got it configured to support mouse and keyboard, but you could obviously turn that to false. Don't support touch, and we only have one type of controller. When I look down here at the types of traits that the PS5 would control, it has this binaural setting configured by OS option, which is used for the audio settings. It needs the brightness adjustment, and we've got supporting mouse and keyboard. If we decided that we don't want to support mouse and keyboard anymore, then we would take off these two settings right here. And now we no longer have mouse and keyboard support. You wouldn't be able to see the cursor when you're moving it around, when you're simulating the platform, and you wouldn't see the options for mouse and keyboard input in the settings screen anymore. All right, back over in the editor. I want to give you now an overview of how CommonUI and Lyra sort of interact. Let's open up the settings screen because it's a pretty good demonstration of how this all works. So if I head over to audio and I adjust the overall volume, we've got these actions that appear on the bottom here. Apply, cancel changes, and back. If I am on a console and I am moving around with the controller, you can see that I have access to these actions not by moving my mouse cursor over them, but by hitting the Y, X, and B buttons. Now let's talk about how this actually is set up and works. So first, we got to head over to C++. So I've got the settings screen class open right here. All right, if we jump into register UI action binding, you can see that we've got a common UI action router base. The UI action router base is something that each local player gets. It's a local player subsystem. When the action binding comes in, it's then registered with the action router, and the action router determines whether or not to fire that action when the user presses the button. Now, anyone familiar with how input works with Slate knows that UI input travels through the widget hierarchy. So if I've got a button focused, that button gets the input first, and then it travels up the widget's parent hierarchy to determine where that input should eventually be handled. Now, for most input, it eventually flows to the viewport, and then the viewport has a viewport client class that then marshals that data to the player input component that each player controller has, which then fires normal game input for Unreal. In order for the UI action router to get that input, what has to happen is we have to replace the viewport client in our game project. So what we have is a Lyra game viewport client, which derives from the common game viewport client. The common game viewport client is something that's part of CommonUI, and it handles all of the cases of input, axis input, touch input, button press input. All those things pass through here and then are then funneled to the action router so that it can determine whether or not it actually wants to handle that input. If it doesn't, then of course it passes on to the player controller and is dealt with there. But back on the Lyra settings screen, let's take a look at what's actually happening here for our case. So we've got the back input action, the apply input action data, and the cancel input action data. If I head back to the editor and I open up the Lyra settings screen, you can see over here, these are those properties. They are assigned a data table entry. The back goes to this universal actions table, which is just a universal entry for the back button on all platforms. Right here, we've got a face button right association. So whatever gamepad you're using, it's the face button right. Save action, the apply goes to a save action that we've got, and that's right here. Just got to apply, or it's the save actions data table. And we've got an apply action and a cancel action, and it gets the text from here, the display name. And then it gets the keyboard button to use, or the gamepad button to use right here. And there's a keyboard association too, if you actually want to have some of these buttons be fireable with a keyboard key instead. All right, now that we've talked about how input works, let's talk about how that input actually arrives at the correct screen that we care about. So in the case of the Lyra settings screen, it's a Lyra settings screen widget. But if I take a look at its base class, it's a game settings screen, which is then a common activatable widget. Now, any widget that is a common activatable widget will have activated and deactivated as actions that they can fire. Common usages for activated and deactivated are things like firing animations, like when a screen first comes up. It's also used for binding and unbinding events that you care to monitor while the UI is active, are the pretty common scenarios. Activated and deactivated are pretty different from constructed and destructed because you can be activated or you can be deactivated and still constructed on the screen, but you simply might not be active and not getting input and not the most important widget on the screen. So you can have a whole hierarchy of activatable widgets, but what's most important is that you are the rootmost activated widget. That determines whether or not you and all of your activated children widgets get input routed to you. Now, how do you determine which one is the most activated root? That one is determined by which activatable widget is currently painted highest in the order of all the other widgets. This is kept track of and monitored by CommonUI. And in order to debug this, because sometimes you can be confused on what things are actually active and what things are not, there's a very useful command called CommonUI dump activatable tree. see how this comes into play in just a moment here. So let's start the game up again. And I'm gonna pull up options, and I'm gonna go over to video, and I'm gonna enter this command into the editor, run it. And then if I open up, our current active root is the Lyra settings screen. We know it's active. It's current layer ID, which is what's important for us. It lets us know what the current bindings are associated with, because we've got those tabs at the top of the screen. Those use the right shoulder and left shoulder buttons on the gamepad, if assuming you have the gamepad as the active input. And then these are our save actions right here. The save, the apply, the cancel changes, and the back button. You can also look at the other activatable widgets that are visible to know, what they're doing right now. So we know that the Lyra front end is currently not activated. So it's not going to get any of the input that is currently being dealt out for back actions and the like. But how do we know to actually put the settings screen on top of all the other widgets? You could just try using add to viewport or add to player screen. Those are the UMG basic commands for adding anything to the viewport. However, those commands don't really take into account any sort of hierarchy you wish to maintain. For example, if I've got a game, I probably care about things like modal dialogues and the HUD, and I want to make sure that the modal dialogues always appear on top of everything else. The problem is, if everybody is just sort of adding to the player screen, it could get a bit chaotic in terms of, what is actually the main thing that we care about. So for Lyra, the way we handle this is the game UI manager. Pop over and take a look at that. The game UI manager subsystem is something we wrote. It's in the plugin called Common Game. Common Game isn't part of the engine. It's a plugin in Lyra. And it's something that we made so that we could basically unify and bring together a bunch of the CommonUI and online subsystem classes and things, and basically sort of knit them all together and make it sort of a common base class for Lyra to then use. That way it's I don't know that we'll ever move this up to engine, but it's sort of the eye we had when we started thinking about some of these ideas. So what the UI Manager subsystem does is it monitors for incoming players, like when they've been added or removed. And then what it does is it tells the current UI policy what to do with those players or what should be done. The UI policy, its main job is primarily to put the primary layout on the screen and determine whether or not to add, remove things from the viewport as necessary. So here's an example of what actually happens when a player comes in. So notify player added. What we do is after the player controller has been set, we actually add the root viewport layout for the player to the viewport for that player. This is important because you might actually have a local player before you actually have a player controller, in which case you want to make sure that it's all initialized before you get it on there. However, it gets it onto the viewport as quickly as humanly possible so that you don't have frames where the UI is invisible. Now, the game UI policy doesn't do a whole lot, but you can always subclass it and add more functionality to it. The real important thing that we care about for Lyra is, and it sort of sets the stage for everything, is the primary game layout. So let's take a look at that. In Lyra, it's called, here's the policy actually in Lyra. The policy class in Lyra is called the Lyra UI policy. It points to a layout class called overall UI layout. If I head over to that, we see the screen right here. It's not very interesting looking, I'll give you that, but it sets up these stacks. We've got the game layer stack, the game menu stack, the menu stack, and the modal stack. You don't have to have all these layers, but you might end up with even more than this. I find that these particular stacks are a pretty easy way to think about game UI, because I think about the game layer as, say, the HUD. I think about the game menu layer as, say, the inventory screen. I think about the menu layer as sort of the settings screen or the frame around the rest of the game that might be running. So you could theoretically be in the inventory screen and then, be dealing with the settings menu or the friends drop down or some other thing sort of on top of that UI. You don't have to do it that way, but that's the way I like to think about it. And then finally, we have the modal stack, which are things like, would you like to exit the game questions? What's not visible here, and that would be required for a shipping game, would be to have things like the disconnected controller UI. You probably wouldn't want to actually have that in a stack. In my head, I initially wanted to put it in the modal stack and just dynamically show it. The problem with that is, what happens if you get a player disconnected controller message? You need to actually have that visible at all times until the player reconnects a controller. and you could theoretically have your widget popped off the stack by an error dialog or something else happening. So in order to prevent that, what you would probably do is actually throw it in the overall layout as just a hidden widget, and then you would show that widget whenever the player disconnected their controller, and then hide it again after the player plugged the controller back in. If you have any other permanent errors like that, you would probably also put them and hide them in the overall UI layout as needed. But you probably only have the player disconnect controller message as the main one in here. All right, so these are my stacks. These stacks are common activatable widget stacks. There are two that CommonUI ships with. They ship with a stack and they ship with a queue. Feel free to use either one, or you could implement your own type of activatable container widget and use those instead if you want a more sophisticated solution to managing these different layers. The stacks work as if I push a new widget onto the stack, it supplants whatever was currently active at that layer. So if I've got the menu stack open and I'm on the settings screen and I press a button that says, show me another screen also on the menu, the game menu stack, then the settings screen will disappear and the new screen that I pushed will appear. And if I deactivate the screen that appeared, I will go back to the game menu. So if I head over to the graph, basically everything I just said, we put down in a comment to help you deal with this if you're not watching the video. But when you create a layer, you'll then register it with the primary game layout, which then knows how to inject new widgets into the different layers when you choose. So this registers each stack and it uses a gameplay tag. So we've got game, game menu, menu, and modal, essentially what I named each one. So if I head back over to the front end, actually let's head over to the Lyra front end. So this is the main screen you get to when you're playing. It is added to the menu layer, and so are all the things that it then spawns, so that it goes away and something else replaces it, rather than showing both at the same time. So we've got the credits, we've got the settings screen right here. The push content layer for player is something that's completely inside of Lyra, just like the whole UI policy and game UI manager. Those sorts of ideas are all coupled together because CommonUI ships with the concept of activated, but it doesn't really tell you how you're supposed to decide where to put those activatable widgets in the hierarchy and how you're supposed to manage that hierarchy of widgets, which is where some of these things come into play. The push content to layer for player, it takes the class and you'll notice here it takes it as a soft class reference. And this is vital because if you use a hard reference to your UI classes for these sorts of operations, your screens they'll quickly load all other screens because you'll create a hard reference, which will, in Unreal terms, will cause, let's say the front end screen will implicitly cause the settings screen and the experiences selection screen. All of those will be forced into memory, even if they're not used yet. So it's important to use soft references for these sorts of operations. This action will also suspend layout for the player until it's async loaded and actually activated, which is great so that when it's activating and when it's being pushed onto the stack, the player can mash any button they want and it won't actually go anywhere, which is, it's a bug you can quickly run into in a lot of circumstances if you don't suspend layout, because all of a sudden they're like deactivating things or deleting things from their inventory because they're pressing the delete button for the inventory screen, even though they don't think they're on the inventory screen anymore. All right, so that's how it works for simply pushing new content onto the stack. And we can pop over here and look at this real quick. So I click on options and you can see, it's hard to see, but you can see that as I go back and forth, you can notice that the Lyra main screen isn't actually visible underneath the rest of the UI. And that's because we're supplanted in on the same screen, or the same layer. Same credits here. All right, so now let's talk about a little bit about how it works in native code 2. Here's a good example. So let's look at the editor preferences, and I'm going to enable PS5 emulation mode again. All right, this main screen that boots up that we press start on to get past, and then brings up the main screen in Lyra. Let's talk about how that actually works. So there is a front end experience, and there's some other videos that will talk about experiences, but all you really need to know is they're kind of like game modes, kind of. What's important here is that when the front end mode or experience starts up, we want to do a couple of things. So there is a component that we want to add. We don't actually want to add any UI, ignore the stats perf container, but what we actually care about is putting the Lyra front-end state component onto the Lyra game state. So the main key difference between these experiences is they're sort of like a roadmap for doing plugin based game development. Rather than subclassing the game mode and sort of hard coding a bunch of stuff, what I'm doing instead is I'm injecting a bunch of components that will customize the game flow and game state of our front end experience here. So let's take a look at Lyra front end state component. All right, it's a game state component, not a huge surprise there. Although it does implement this interface called iLoading process interface, which is great because what the loading screen manager does, which is another plugin in Lyra, is it will examine any components on the game state. And if they implement an iLoading process interface, it will ask them about questions like, should I still be showing the loading screen? Which is really handy when you are async loading a bunch of UI and you don't actually want to drop the loading screen just yet, because loading is more than just something in memory. It could mean things like, hey, have you actually logged in to the platform yet? Or have you logged into a backend database yet? All right, so I'm going to look at onExperienceLoaded, which is a callback that we're going to get because we set it up in begin play. What we're going to do in here is we're going to wait for a user initialization to happen, which is the initialization for basically resetting the sessions and resetting the user state in some cleanup work that we have to do. We have to do that every time, but we use this flow control, their control flow class to sort of manage these async tasks. Each one of these steps could finish immediately, or they could finish in a couple of seconds, but this allows us to sort of write it as if it is a linear set of steps. All right, so now let's look at flow step, try, show, press, start screen. So inside of here, we first determine whether or not you're already logged in, and if you are, you can just bypass this whole flow. But if we're not sure yet whether or not you've already logged in, and by login, I don't mean to say like your backend service, I mean to the console. So for console games, you need to know which person is pressing the button to know which player to actually associate the gameplay with. So we can ask the user subsystem, which is another subsystem in common game, whether or not we should actually wait. And so this checks a couple of things, but it decides whether or not we show the screen. And if we're not going to show the screen, then we move on. But if we need to show the screen, then what we do is we grab the primary game layout, which is just what we talked about earlier. We've got the primary game layout for each player. And then what we're going to do is on that layout, we're going to call push widget to layer stack async. And we're going to suspend the input until it's complete. And just like in Blueprints, we're going to push it to the layer menu. And after it's pushed, we're going to wait for it to be deactivated. And once it's deactivated, we'll continue the flow. So this is where the control flow system actually comes into play. You should take a look at that more if you're interested in it. But it's super helpful when you're trying to do these situations where you've got a bunch of async operations that may involve user async as well as just like loading async. So the user finally decides, oh, okay, I press the button, a bunch of stuff happens, but all we really care about in this screen is continuing the flow. If we somehow cancel the async loading, then we would just continue. It's sort of in case something horrible happens. You'll also notice that after we push this widget onto the stack, we actually kick a flag that says, should we still be showing the loading screen? We set that to false. So this is really useful, again, for the loading screen situation up here. So if once we actually have some UI on the screen, we can go ahead and tell the loading screen system, hey, this component no longer blocks the loading screen. Some other ones might, but we no longer do. And then, of course, if you follow the control flow up here, the other thing we do is we try to show the main screen, which is how we actually show the main front-end widget when you first come into the game. So the front-end state component is a super useful thing because you don't always necessarily show the same widget every single time. And it's a useful pattern when you're dealing with circumstances like this, where you might actually need to show different UIs dynamically, or you might need to, you just don't necessarily know which one you're going to show always.
Hey, I'm Reese Harwell, and I'm a UI artist at Epic Games. Today I'd like to talk to you about the benefit of using materials as a foundational UI art asset in UMG, and why you might choose them over bitmaps in parts of your UI. So, let's begin. So, why might you choose a material-heavy implementation method for your UI? Well, first, perhaps it's just to reduce the memory taken up by UI bitmaps in certain places. Or maybe it's to reduce the overall texture budget of the game, in particular UI. Or perhaps you need the performance gains of a reduction in the number of layers, draw calls, and widgets within your UMG hierarchy. You might also choose materials because you think you'll need to fine-tune the visuals for certain elements based on the game's context by editing it while it's at runtime or by decreasing the iteration loop for fine-tuning parts or visuals or pieces or animations. Or perhaps it's just because you anticipate needing to make a lot of the elements in your UI dynamic, and especially dynamic based on game contexts. For me, a lot of those last points are really important. I always think to myself, it's incredibly unlikely that a player will ever have access to and interact with any of my design files. So the source of truth for everything I end up making is the end software. That's the piece of software the user will interact with. So my feeling is that if I'm not adjusting my decision making with art or design or really anything with the game's context, then I'm probably missing out on important details and important polish. So in the case of Lyra, I built most of the UI with very little bitmaps, primarily to show off, how extensible they are and how useful they are for managing states, managing colors, managing decisions, and to show off their runtime editing and tuning capabilities. Materials are not without a downside. Probably the biggest one is the amount of time that is needed within the material graph to create the building blocks that you use everywhere. It's going to be probably a good bit slower than creating that same asset in texture form. But again, what you get for that is something that's a lot more dynamic, a lot more extensible, and a lot more editable after the fact. So let's get to some examples. Okay, so for this first example, I want to show you the ammo counter in Lyra. And it is just the dashed arc beside the reticle. And if I change weapons, you can see I have 3 slightly different presentations for it to match the different weapons. And if I fire it, it's kind of just showing me the ammo current versus the max. If I fire it down low enough, I hit this little low ammo warning, and all the counters are the same in that way. So what's cool about this right off the bat is that the base material in this case covers all 3 different versions. If we had 50 different weapons in Lyra, we could have 50 different designs built from this same base material because it is built to cover any type of dash radial fill within the constraints that I've set up. So let's edit the rifle here and show you. Let's say I wanted it at the top. So let's just put it up at the top. Let's say I wanted more range to it, something like that. And I wanted the rounds to be like thicker and more spaced apart. Let's just tune up the sharpening there. Okay, so let's say I was happy with this. Well, I could save this off as one of my designs, and it's that easy and fast to edit because I spent the time to build this in a material, and I built a tool that can be extended in this way. The presentation is manipulated via parameters that I get to define, and I can make as many versions with those parameters as I need or as the game needs. So if I go back to Pi, you can see, if I switch to the rifle, you can see that it's been edited. Well, another really cool thing about materials is that all of those changes that I was just showing you can be updated at runtime. So let me get this, do some window management for you here. I do recommend 2 monitors. Okay, so let's say I wanted it over there on the right instead. And I wanted even more range on the counter. And basically all these edits that I'm making, you can see are updated and reflected real time with the game. And what's cool about that is the iteration loop there is very small. We've all kind of been in that situation where we're editing an asset in a design program, then we save it, then we have to load it into the engine, run the game, and get into the game context where that piece of UI is being rendered. And that's a pretty long iteration loop. Well, with a material, that iteration loop can be very small. You can match it perfectly to the game's context. And there's plenty of, gameplay moments that you're gonna want to fine-tune something based on the gameplay. And in those cases, I think materials are a great application for that. It's my belief that the game is the best context for editing your UI, and no design program is the game. So another cool thing is I can store choices about my presentations in material instances. So for example, with this, I have set up the rifle to be the parent of the pistol and the shotgun. So let's say I wanted to change the low ammo warning here to flash faster, and I wanted like more saturated colors to them. Let's change that. You can see that's changed. Well, because this is the parent to the shotgun and the pistol, if I look at those, they're also reflecting that change. So material instances become a convenient place to store decisions that you want mapped across a set of instances. So that's not all, because essentially this ammo counter is maybe just like a slightly fancy radial fill. Well, that means it could just be a radial fill. And if I extended it to be a radial fill, it becomes a building block for a whole other set of assets. And I've done just that. So if I go over to Reference Viewer, you can see here's the base material, and here's the ammo counters that I was just showing you. Well, here's also the respawn timer, which is just kind of a simple radial fill. Here's another radial fill associated with the team score and the other assets associated with that, the glows and different team colors. And then I've also got the loading spinners in here because it's kind of just a softer radial fill that just spins. So I've set it up to do that as well. So with this one material, I've created a building block that I can extend to other pieces of the UI. And, based on how good your planning is and how far out you can plan, you could create a bunch of base materials to extend to tons of different pieces in your UI art. And then just a couple housekeeping notes. You can see I've used a fair number of static switches in here, and that's just so I don't have to pay the instruction count for all the different pieces just associated with the ammo counter or just associated with a loading spinner or whatever. And then one other note, I kept the UV math on the ammo counters and the radial fill square because it was easier to set it up like that, but I don't want to have to pay the instruction cost for all of that alpha, so I ended up just using UMG to clip that out. And if I set this clipping to clip to bounds, it will clip out all of that pointless alpha that you don't want to have to pay the material cost for. All right, so I wanted to show a couple more examples of the convenience of materials in UI, talk about MIDs and some other development circumstances in which materials can be a little more malleable than bitmaps. So in this first example, I'm going to talk about the control points. So very unlike the ammo counters in the previous example, there's plenty of situations when making UI that it can be time consuming or difficult to get the UI showing the proper gameplay context for you to be able to tune it at runtime. And that could be for various reasons. It might not have been built yet, or the context, you need a backend or profile setting changed for it to draw on screen, or maybe it requires like 16 players to show or whatever. And for this control point, I had that situation where the logic for the actual widget hadn't been built out. In fact, when I started, these indicators weren't built at all. There was just the score showing the total of each red and blue team score. Now, ultimately, I knew I would need to update parameters dynamically in the material. So when I built it, I pushed all the game state information into a single group called this animators up at the top so that I could visually tune what I wanted the states to look at like prior to the logic even being built for it to work. And you can see up here, I can change the point from red to blue, and obviously I could tune the colors if I wanted. I can show the point flashing, which is just indicating if it's being captured, if the point has been captured or if it's empty, and then if it's contested or not, which will alternate between the red and blue in this situation. And then like I'm saying, if I wanted to tune this currently, I could adjust things. Let's say I wanted the speed and the flash to be super fast. And if you go into the blueprints here, I did end up obviously working on the logic of this and making it all work, But like I was saying, I had pre-set up the material to be driven with these parameters, and that's all I'm doing with the logic. So I ended up grabbing the control point volume and seeing what teams they're overlapping and seeing how many teams and who was the owner of the point, etc., just to basically drive different states within that material instance. So if I look at that ring that we are editing, the first thing I do is I set a dynamic material instance. Then on that dynamic material instance, I'm just updating those same parameters. And we can see this working. If I enter the point, you can see the visuals are identical to what I was showing you in UMG design view. And if we contest the point, it's going to alternate. And then if I exit the point, it'll go back to blue. So for this next example, this is the health bar. And similarly with the control points, I wanted to tune the visuals for taking damage or getting healing, but I didn't want to have to do that at runtime because those are really transient states. And the delta of showing damage or healing would only be on screen for a very brief time. So yet again, I'm using material instances for that. So with this taking damage, you can see I've got an animation that drives it, and looking at the animation, it is mostly just editing material parameters. I've also got some other animations in here, again, mostly utilizing a lot of material parameters. This is getting spawned. And then on healed, that's messed up, and I'll tell you why that is. But first, let's look at damage. So if I wanted to see what taking a little bit of damage would look like, all I would need to do, because the way I've set the material up, is set my updated damage to be a slightly smaller number than my current. So that's taking a little bit of damage. And then same thing for taking a lot of damage. Now with healing, the reason this wasn't working is because going from current to updated, it would need to go the other direction to be healed. So my current health would need to be lower than my updated health. Now you can see the animation working. And then similarly, if I just wanted to see a little bit of health, or a lot, the material instance allows me to visualize that. One other thing with the health bar that I'd like to show is within the material, I've gone to the trouble of building this fully in material, so I'm not using any bitmaps for it, which means I'm variably sharpening all my edges and pieces of the health bar. So if I zoom in, you can see this is at a zoom level of 4. You know, the anti-aliasing on the rounded corners looks pretty good. If I zoom all the way in, it starts to kind of look a little fuzzy. So if we were at whatever crazy resolution this would be, you would start to see some of that softness. Well, if I have gone to the trouble of building it all in materials, and I am variably sharpening these rounded edges, I would just need to introduce the pixel dimensions of the brush to variably sharpen it based on its draw size, effectively making a dynamic resolution-based anti-aliasing edge. So I've kind of crudely set that up as an example, and let me pull up the material. So basically inside this material function that I made, you can see it's pulling the pixel dimensions off of the brush, and it uses that to create a ratio to multiply the sharpness value by. So I'm going to hook that up. And once it finishes, if I go back to the health bar, and I'm going to actually tune the sharpness down a little bit on this, like 6, and maybe a little less. You can see that as I zoom into this, the soft edge maintains like perfect anti-aliasing. And I can do that on the widget as well. So let's pull up the widget. As I zoom, it maintains its sharpness without being overly sharpened or not sharpened enough. And I just want to show that because it shows that materials are a possibility space with UI that can potentially create resolution independent graphics, much like vectors. Okay, so I also wanted to talk about something I mentioned at the top, and that is how materials can help reduce the number of layers and draw calls and widgets in your UI. And in this example, while it's still got a few layers, most of the visuals are driven through this individual layer, as well as all the states. So it's got this cooldown state that goes from empty to fill, and it's got this flashing active state that flashes that and then collapses this additive boost, glow boost. But for the most part, all the visuals are packaged into a singular layer. And you know, I could have added this border and the shadow as well to this single material if I wanted to. There might be times at which you'd want to highly scrutinize each layer in a widget. So, you know, a big inventory where you've got tons and tons and tons of the same widget on screen, you're going to want to reduce that because the total number of items on screen. So looking at the material for this, we've got the weapon card material that it's its parent, and you can see all the layers I have in here. I have the icon for the actual weapon. I've got this pattern that is the triangles in the background for its active state. I've got active colors, inactive colors, empty, and then various settings for setting up its shape and the roundness on it and sharpness. And you can see in the child instance of that, it's mostly just turning on its cooldown and changing the icon out. So another example of that is the menu button in Lyra, and it's similarly set up where you've got a glow and then this optional ring border on the outside of it, but most of the visuals are driven through this singular layer, which is in a border. And if I open up that material, you can see all the states in here. I've got my hovered states and my press disabled. I've got the edge colors, the edge brightens a little bit relative to the center, etc. And if I open up Pi, you can see the different states here on the button. In this case, it actually just has a hover state, but if we needed the button to be a selectable button, it's got that in there too. And just like all our other examples, if we wanted to change the presentation at runtime, we could pretty quickly and easily. And let's make this red too. And it's that fast to change every single button in the game to having a red hover state. I guess except this tab, because the visuals are slightly different. But it does include these tiles, and these tiles, and these buttons, and even our quit button. So one other thing to mention with the widget setup here is that the way this is built is it's got a few functions in here to update the visuals of the button. And basically this just surfaces a bunch of options to instance versions of this widget. And if we look at the reference viewer on this widget, you will find that it has been subclassed. So the parent class of this widget is that button I was just showing you. And within it, I have just edited a few different types of the presentation. And that's why I carry over everything over from this parent widget. Similarly to like a material and a material instance relationship where I'm just editing the things that are different about this button versus its parent. And if I go back to reference viewer, you can see I've got a few different buttons in here. Let me increase my depth. You can see that I've subclassed it a few different times to do just that, to extend the presentation to different styles. And that's why when I changed that hover state just in those two materials, every single button in the game was updated. And lastly, I just want to make a quick note about how useful materials are for animations. Basically, anything that you parameterize can be edited as part of an animation, and it just gives you a lot of flexibility with your animations to, you know, adjust minute things, thicknesses, sharpnesses of things, as well as, you know, your typical scale and alpha and blends and colors. So I picked out a few different examples. This is the victory sequence or the defeat sequence. There's also the elimination animation for the shotgun, and you can see primarily it's just, well, actually entirely it's just using one layer here and just animating a bunch of material instance parameters. Let me play that a little slower. And then this start sequence, which, if you look closely, you can see it's using the ammo counter base material because it's a radial fill and it's just using one of the spinners. And that's all I've got. Thanks for the time.